This is SpaceTime, Series 25, Episode 59. Coming up on SpaceTime, the Sun as you've never seen it before. The end is near for NASA's Mars InSight lander, and the mysterious origins of the dwarf planet Ceres. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Powerful flares, breathtaking views across the solar poles, and a curious solar hedgehog are among the treasure trove of spectacular images and data now being returned to scientists by the European Space Agency's Solar Orbiter spacecraft following its first close approach to the Sun. Although the analysis of this new dataset has only just started, it's already clear that this mission is providing the most extraordinary insights into the Sun's magnetic behavior and the way this shapes space weather. Now, as we reported at the time, Solar Orbiter's closest approach to the Sun, known as perihelion, took place 2 months ago on March the 26th. The spacecraft was inside the orbit of Mercury, about 1/3 of the distance from the Sun that the Earth is, and its heat shield reached temperatures of over 500 degrees Celsius. Solar Orbiter carries 10 science instruments, all working together in close collaboration to provide unprecedented insights into how our local star works. Some are remote sensing instruments that look at the Sun, while others are in situ instruments that monitor the conditions around the spacecraft itself, enabling scientists to join the dots from what they see happening at the Sun to what Solar Orbiter feels at its location in the solar wind millions of kilometers away. When it comes to perihelion, clearly the closer a spacecraft can get to the Sun, the finer the details the remote sensing instruments can see. And as luck would have it, the spacecraft also soaked up several solar flares and even an Earth-directed coronal mass ejection, thereby providing a taste of real-time space weather forecasting, an endeavour that's becoming increasingly important because of the threat space weather poses to technology and astronauts. These space weather events can damage or even destroy spacecraft by short-circuiting their delicate electronics. They puff up and expand the Earth's atmosphere, causing increased atmospheric drag, which can cause orbital decay or shorten the spacecraft's life because it needs to use more fuel to remain in operational orbit. Space weather also affects navigation and communication systems and has caused power blackouts on the ground. The radiation produced by space weather events can also affect the health and safety of astronauts. So the more we know about space weather or when to expect an event, the better it is. Solar Orbiter's Extreme Ultraviolet Image Instrument Principal Investigator David Bergsman from the Royal Observatory in Belgium says the new high-resolution images of the lower layers of the Sun's atmosphere, the solar corona, are absolutely breathtaking. This is the region where most of the solar activity which drives space weather takes place. One especially eye-catching feature has been nicknamed the hedgehog. It stretches some 25,000 kilometers across the Sun and has multiple spikes of hot and colder gas which reaches out in all directions. Solar Orbiter's main science goal is to explore the connection between the Sun and its heliosphere, the Sun's solar wind of charged particles which blankets our entire solar system in an atmospheric bubble. It's the movement of these particles and their associated solar magnetic fields which create space weather. Studying the Sun's effects on the heliosphere and the solar magnetic field as it leaves the Sun's visible surface, the photosphere, is a complex task, as the magnetic environment around the Sun is extremely complicated. But the closer a spacecraft can get to the Sun, the less complicated it is to trace particle events back to the surface along the magnetic field lines. A few days before perihelion, a cloud of energetic particles sweeping across Solar Orbiter was detected by the spacecraft's energetic particle detector. Tellingly, the most energetic particles arrived first, followed by those of progressively lower and lower energy levels. Now, what this suggests is that these particles weren't being produced close to the spacecraft, but were being produced in the solar atmosphere nearer the Sun's surface. And while crossing space, the faster, more energetic particles moved ahead of the slower, less energetic ones. On the same day, another instrument, the radio and plasma waves experiment, saw these particles coming, picking up the strong characteristic sweep of radio frequencies produced when accelerated particles, mostly electrons, spiral outwards along the sun's magnetic field lines. The instrument detected oscillations known as Langmuir waves, a sign that the energetic electrons had arrived at the spacecraft. Meanwhile, Solar Orbiter's Extreme Ultraviolet Imager and its X-ray spectrometer telescope saw events on the Sun which could have been responsible for the release of the particles. Now, while the particles that stream outwards into space are the ones the energetic particle detector and radio and plasma wave experiment detected, it's important to remember that other particles can travel downwards from the event, striking the lower levels of the Sun's atmosphere. And this is where the X-ray spectrometer telescope comes in. While the Extreme Ultraviolet Imager sees the ultraviolet light released from the side of the solar flare in the Sun's atmosphere, the X-ray spectrometer telescope sees the X-rays that are produced when electrons accelerated by the flare interact with atomic nuclei at lower levels in the Sun's atmosphere. There's some indication from the composition of the particles detected by the energetic particle detector that they're being accelerated by a coronal shock in a more gradual event rather than impulsively by the flare. And that suggests multiple acceleration sites. But adding another twist to this situation was the fact that the magnetometer instrument failed to register any substantial event at the time. However, that's not necessarily unusual. The initial eruption of particles, known as coronal mass ejection, carries a strong magnetic field which the magnetometer can pick up. If the coronal mass ejection misses the spacecraft traveling in a different direction, the magnetometer simply won't see it. When it comes to the magnetic field, it all begins at the Sun's visible surface, photosphere. This is where the internally generated magnetic fields first burst onto the surface. To know what this looks like, Solar Orbiter carries a polarimetric and helioseismic imager, which can see north and south magnetic polarity on the photosphere, as well as the rippling of the Sun's surface due to seismic waves travelling through its interior. This field then expands as it goes into the corona and drives all the action up there. Another instrument, the spectral imaging of the coronal environment, records the composition of the corona, which can then be compared to the contents of the solar wind seen by the solar wind analyzer. Another instrument, the spectral imaging of the coronal environment, records the composition of the corona, which can then be compared to the contents of the solar wind as seen by the solar wind analyzer. This tracks the evolution of the composition of the solar wind from the Sun to the spacecraft, and that tells scientists a little bit about the mechanisms responsible for acceleration of the solar wind. So, by combining data from all these instruments, the science team were able to tell the story of solar activity from the surface of the Sun all the way out to the Solar Orbiter spacecraft and beyond. And it's that knowledge which will help pave the way for future systems which will be able to forecast space weather conditions on Earth in real time. This is SpaceTime. Still to come, the end's getting nearer for NASA's Mars InSight lander and the mysterious origins of the dwarf planet Ceres. All that and more still to come on SpaceTime. Dropping power levels are likely to bring an end to NASA's Mars InSight lander mission before the end of this year. Mission managers say dust on the solar panels, combined with darker skies over the red planet, are diminishing power levels and forcing scientists to turn off various instruments not in immediate use. Despite power conservation attempts, it's now expected that InSight will be inoperative by December, concluding a mission which has thus far detected more than 1,300 Marsquakes. Most recently, a magnitude 5, which occurred on May the 4th and located in a quake-prone region of the red planet. The information gathered through these Marsquakes has allowed scientists to measure the depth and composition of the Martian crust, mantle and core. Interestingly, scientists also found that the occurrence of Marsquakes appears to be seasonal in nature, but they have no idea why. Having now recorded data for 2 Mars years, that's 4 Earth years, they know the data is not just a fluke because they can see the same pattern repeating, with more quakes at specific times of the year. But as to why the quakes occur in this way remains one of the red planet's biggest mysteries. Scientists also noticed that there are fluctuations in the Martian magnetic field that can be minutes long or even shorter. Some look like little waves in the magnetic field, but researchers have no idea why they're happening. Is there also a seasonal dependence on their occurrence? Or are they all resulting from the same cause as the Mars quakes? InSight's also recorded invaluable weather data and it studied remnants of Mars's ancient magnetic field. The director of NASA's Planetary Science Division, Laurie Glaze, says InSight has transitioned science's understanding of the interiors of rocky planets and set the stage for future missions. Researchers can apply what they've learned about the red planet's internal structure to the Earth, to the Moon, to Venus, and even to rocky planets in other solar systems. InSight landed on Mars back on November the 26th, 2018. The spacecraft is equipped with a pair of 2.2-meter diameter solar panels which unfurled fan-like upon landing. InSight science team investigator Katherine Johnson says the probe was the first mission to study in depth the inside of Mars, its crust, mantle and core. It made measurements of ground movement, providing seismic data as well as local temperature, wind, air pressure and even magnetic field changes. Johnson and colleagues learned how strongly magnetized the rocks beneath the landing site are, and that there are time variations in the planet's magnetic field, probably related to magnetic fields generated by electric currents in the atmosphere or above by solar winds. They also found that just like Earth, there are also variations in the magnetic field between day and night. InSight also measured the planet's rotation with far greater accuracy than previous spacecraft. Unlike many other Martian probes, InSight's been a stationary lander because the seismometer needs to remain in one place in order to measure very tiny ground motions resulting from Mars quakes. The lander was designed to accomplish the mission's primary science goals in its first Mars year, equivalent to nearly 2 Earth years. Having achieved its primary objectives, the spacecraft then transitioned into an extended mission. However, its solar panels have been producing less and less power as they continue to accumulate more and more dust. Now, because of the reduced power, mission managers have now placed the lander's robotic arm into its final resting place, known as its retirement pose. Originally designed to deploy the lander's seismometer and heat probe, the arms played an unexpected role in this mission. As well as using it as a hammer to try unsuccessfully to bury the heat probe into the sticky Martian soil, mission managers also used it as an innovative way to remove dust from the solar panels. As a result, the seismometer was able to operate far more often than what it would have otherwise, thereby leading to new discoveries. When InSight landed, the solar panels produced around 5,000 watt-hours each Martian day or sol. That's enough to power an electric oven for an hour and 40 minutes. But now they're only producing about 500 watt-hours per sol. That's only enough to power the same oven for roughly 10 minutes. Now, adding to the problem are seasonal changes which are starting to take place in the skies above the Elysium Planitia landing site. You see, over the next few months, there'll be more and more dust in the air. That will reduce sunlight and therefore the amount of energy the lander receives. While past efforts have removed some dust from the panels, the mission would need far more powerful dust cleaning events, such as passing whirlwinds or dust devils, to reverse the current trend. Of course, similar winds have helped solar panels on both the Spirit and Opportunity rovers, keeping them operational for years longer than expected. But if just 25% of InSight's panels were swept clean by the winds, the lander would gain about 1,000 watt-hours per sol, enough to continue collecting science. However, at the current rate of power depletion, InSight's non-seismic instruments will now need to be left off. Energy is now being prioritized to the lander's seismometer, which will operate at select times of the day, such as at night, when the winds are low, and so Mars quakes are easy for the seismometer to hear. At the current rate of power loss, the seismometer itself is expected to be offline before the end of August. And that will effectively conclude the science phase of the mission. At that point, InSight will still have enough power to operate, taking occasional images and communicating with Earth. But the team expects that around December, power will get so low that one day it'll simply stop responding and the mission will be over. This report from NASA TV.
InSight has been fantastically successful. We've gotten more science than we had ever dreamed that we would get during the course of this mission. InSight's primary goal was to better understand how the terrestrial planets, the rocky planets, formed and evolved.
First, we landed an incredibly sensitive seismometer on the surface of Mars, and with that, we were able to record over 1,300 Mars quakes.
And these range all the way from tiny little tremblers that just barely go over the noise background to a handful of quakes that were larger than magnitude 4.
And feeling those vibrations, the scientists can actually take that information and use that to reconstruct all the material that those Mars quakes traveled through and thereby see the interior of the planet.
We looked at its core, which is big and not very dense. We looked at its mantle, which is not so hot. And we looked at its crust, which is not too thick and not too dense compared to some of our pre-mission expectations.
By measuring the detailed structure of the inside of Mars, it gives us a snapshot of what the planet looked like 4.5 billion years ago. The other thing that we've been able to do is make a very detailed record of the weather at Mars. So we have a really good weather station, which has allowed meteorologists to study the weather at the InSight landing site and relate that to the climate changes on Mars.
What we didn't do, unfortunately, was make the heat flow measurement we wanted to make. Our heat flow probe was supposed to get 3 to 5 meters down, and we were unable to reach that depth.
But we were able to get some of those measurements, such as the heat transfer amongst the soil.
InSight is a solar-powered mission. We have solar panels, and they were designed to give us enough power to easily get through the first 2 years.
But there's a lot of dust in Mars' atmosphere, and that's falling down on top of our solar arrays and slowly blocking the sun.
As the panels are getting dustier, we started racking our brains with whether there's anything we can do to try to clean off those panels ourselves.
When the idea of using dirt to clean the solar arrays was first proposed, it seemed counterintuitive.
We were actually able to use the arm and the scoop to scoop up some soil from the ground and dump it over the lander, having some of that heavier sand blow onto the arrays and knock some of the dust off. So we essentially used it as an array cleaning tool.
Cleaning with dirt actually worked.
It allowed us to actually keep the instruments going during the low power season where the Mars is farthest from the sun during the winter. Unfortunately, later this summer, we think that the power is going to be dropping so quickly due to the atmosphere getting dustier, due to the alignment of Mars and the sun.
We're going to be at a point where we can no longer have all of our instruments on, which means we'll be turning off the seismometer and other instruments on board.
The last day is going to be bittersweet. Obviously, we're preparing for it. We know it's coming. But that first moment where we don't hear from the lander when we expect to, that's going to be tough.
It's left a permanent mark on me. I literally tattooed InSight onto my arm. I'll never let it go.
We've really rewritten sort of the chapter of the encyclopedia on the interior of Mars. That was our last big hole in our understanding of the planet.
There's a lot of data that people are going to be looking at for decades to come.
We accomplished so many of our science goals, and we're going to have something to look back on and be proud.
And in that report from NASA TV, we heard from InSight Principal Investigator Bruce Bannett, InSight Project Scientist Mark Panning, InSight Science and Instrument Operations Lead Elizabeth Barrett, and InSight Deputy Project Manager Katia Zamora Garcia. This is SpaceTime. Still to come, the mysterious origins of the dwarf planet Ceres, and later in the science report, a disturbing new study shows that more than 1 in 10 people may be conscious during general anesthesia. All that and more still to come on SpaceTime. A new study claims the largest main belt asteroid, the dwarf planet Ceres, was likely formed in the coldest part of the solar system before being flung into its current orbit between Mars and Jupiter. The findings, reported in the journal Icarus, are based on observations showing that Ceres' composition is significantly different from other main belt asteroids, suggesting a different origin. By main belt asteroid standards, Ceres is a monster. It has a diameter of almost 1,000 kilometers, contains a full third of the asteroid belt's total mass. Its orbit around the Sun is almost perfectly circular, with a 0.09 eccentricity and an inclination of 9.73 degrees to the plane of the solar system, much greater than Earth, which is 1.57 degrees. Ceres has too little mass to retain an atmosphere by gravitational attraction, but sunlight does evaporate the ammonia and water ice from below the surface, forming a sort of exosphere mist which dissipates into outer space. Ice deposits shine brightly at the bottom of its deeper craters, and the possibility of primitive life forms on Ceres has not been ruled out. The craters were mapped by NASA's Dawn mission, which orbited both Vesta, the second largest body in the asteroid belt, as well as Ceres. The dwarf planet's core is probably made up of iron and silicates, but what differentiates it from nearby objects is its mantle of ammonia and water ice. Most bodies in the asteroid belt do not have ammonia, so the hypothesis is that Ceres must have formed further out in the colder regions beyond Jupiter's current orbit, and then was somehow thrust into the middle of the asteroid belt by the huge gravitational instability caused by the formation of the gas giants Jupiter and Saturn. The study's lead author, Rafael Ribeiro de Souza from Sao Paulo State University, says the presence of ammonia ice provides strong observational evidence that Ceres may have been formed in the coldest regions of the solar system, well beyond the snow line, in temperatures low enough to cause condensation and fusion of water and volatile substances such as carbon monoxide, carbon dioxide, and ammonia. Today, the snow line is located within the main asteroid belt near the orbit of Jupiter. But when the solar system was being formed 4.6 billion years ago, the position of this zone varied according to the evolution of the protoplanetary gas disk and the formation of the giant planets. The intense gravitational disturbance produced by the growth of these gas giants may well have changed the density, pressure, and temperature of the protoplanetary disk, displacing the snow line. And this disturbance in the protoplanetary gas disk may have slowed the orbital speed of the growing planets Jupiter and Saturn, causing them to migrate closer towards the Sun. Now, under the so-called grand tack theory, after they clear this gas, Jupiter and Saturn then began to migrate back out again to their current orbital positions. The study's authors suggest that Ceres must have begun forming in an orbit well beyond Saturn, where ammonia was abundant, but was then gravitationally perturbed into its current orbit by the outward migration of the gas giants. To test this hypothesis, Ribeiro de Souza and colleagues ran a large number of computer simulations of gas giant formation inside the protoplanetary gas disk that surrounded the early Sun. In their model, the disk contained Jupiter, Saturn, embryonic planets, which were the precursors of the ice giants Uranus and Neptune, and a collection of planetesimals, similar in Ceres to size and chemical composition. The assumption was that Ceres was one of a class of bodies thought to have been the building blocks of planets, asteroids, and comets. The simulation showed that the gas giant planet's formation stage was highly turbulent, with huge collisions between the precursors of Uranus and Neptune, the ejection of planets out of the solar system, and even invasion of the inner solar system region by planets with masses greater than 3 times that of the Earth's mass. And these strong gravitational disturbances would have scattered objects similar to Ceres everywhere. Some may well have reached the region of the asteroid belt and acquired stable orbits. Ribeiro de Souza says 3 main mechanisms acted on these objects in the region: the action of gas, which smoothed their orbital eccentricities and inclinations, resonances with Jupiter, protecting them against ejections and collisions caused by that giant planet, and close encounters with other embryonic planets, scattering planetesimals to more stable inner regions of the asteroid belt. The author's simulation suggests there were at least 3,600 Ceres-like objects beyond Saturn's orbit. The findings match previous works by other groups based on craters and on the estimated populations of the Kuiper belt beyond Neptune, where Pluto and other dwarf planets still reside. This is SpaceTime.
And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.